Welcome back. Finally, the last module. Now, in this module, we'll talk about how to do maintenance and monitoring. Now, the need to maintain and monitor are impossible to separate from the need to ensure performance. How does your app behave when too many users are accessing it? Do you need to change design? A tool to help you, that is called load testing, will generate fake traffic to test if your app goes down during heavy access. Now, Azure Load Testing Preview is a fully managed load testing service. It offers automated load testing that run on the cloud. You can write test script based on Apache JMeter and industrial standard. You can also automate regression testing by running load test as a part of CI/CD pipeline. Now let's take a look at it in a quick demo. So for time purpose, we have skipped the following things like creation of repository, creation of project on Azure DevOps, connecting from Azure DevOps to the repository. And we have just came right to the creation of Azure Load Testing resource on the Azure Marketplace. Just click on the button here. It is going to ask you to choose Azure DevOps project and just click Install. And click on Proceed to Organization. This will bring us to Azure DevOps project. And we can create a new pipeline and just edit its definition here. We'll need a few things like the subscription ID, copy it over from the Azure portal, and the name of load testing resource that we just created, the resource group and the region, which is written here as location, and then we'll save it. And the pipeline should automatically start running. So we have fast forwarded a little because the pipeline takes time to run. And now you can see it has finished the build and deployment, and we are close to the end of load testing too. You can check out the results of the load testing. Click into load test button, and it should pull up the log. You can see the metrics such as response time, the total number of requests, etc. If you click into artifacts, this should give you the test results. And we can come over to the GitHub repo to add a failure criteria. This defines the acceptable failure when we actually run these tests. And we set it to response time longer than 100 milliseconds, percentage of error over 20%. Once we commit this, it will trigger the pipeline to run again. So we have fast forwarded again to let the pipeline run. Again, we are close to the end of load testing. And this time it has failed. We can click into load test tab to see why. And we can see in this step, the failure has exceeded what we defined as acceptable. Over in the repository, which are the average response time and the overall percentage error. Let's assume we think this is too strict. We can go back and change it. So we'll change the criteria to acceptable response time equal to 5,000 milliseconds, and the error rate stays the same. And now the pipeline will run again. Now we have skipped to the end of the pipeline run, and you should see that the test shall pass. Now back to Tailwind traders. This time, we want to understand application behavior. Make sure someone is responsible when an incident happens. Set up automation in incident response to make it easier. When we say understand app behavior in prod, we mean to monitor and see if it works as we envision it to. Now we want to improve time to detect issues, example bugs, attacks, and threats, and become faster in responding to these issues. And also ensure that we have the metrics to validate learning. Now, validated learning is a term in Scrum used to describe a small unit of progress that can be verified by the goal we set up before implementing it. Example, releasing a series of new features through A/B testing and check the adoption rate to check if the users indeed like them or not. Now, our data sources in monitoring include real users, synthetic transactions, which is the data coming from scripts simulating user behavior. Example, you can create a script that simulates a user going to a website, clicking on a button in navigation, and watching a video, and so on. Telemetry, example CPU or memory usage. Now, you need to define the monitoring practices to make it effective. But what do you monitor? Why do you do that? How long do you keep them? Who needs to know what? Now, depending on the scale of the app, this may be a multi-stage and a complicated process. Now, time for a quick demo. Now, this is the Tailwind Traders' primary e-commerce website. Our team is responsible for this website. We've got a lot of different products on it, which we see as we navigate around. One of the great things we have done as part of our building the software and getting it deployed is that we have it instrumented. We can tell the problems or potential problems, and we do that through application insights. In an Azure portal, we can go look into the information about how our application is running. It's showing me here we've got some failed requests, and we've got some successful traffic coming through. Great. Let's dig in and see what's going on. This application is a microservice-based architecture, which can make tracing problems difficult. So for that purpose, I really like application map. The application map lets us see the distribution of the services, the calls and traffic between them. We can see information about slow and failed calls, and we can dive into and dig into our individual errors. We have different views of the groups of error, and we can see specific log entries that show us, or some of the problems in our code might be. Now we have some troubleshooting information, but we can go even further. For example, take a look at these dependencies which are causing the problem. We can use the information that we are going to find in the log to help create some custom alerts for things that our team cares about. In this case, we care about failures and these dependencies inside our application, which lead to poor user experience. I recognize that some of the calls that are being made are either coming from web client or some other API. This is definitely a problem that we need to be aware of. Clicking through there gives us a good query to see those details. And from there, we can create an alert. We can take the default query to create that alert, but we'll need to adjust it a bit. It's hard-coded to current time that we exported from, and we want this thing to be able to flow and change over time. This query has more details used for reporting, so we can really streamline this thing down. And I really do suggest that we start with very streamlined query. When we start with a new alert, we want to keep it simple. Now, let's get rid of these times. I do want a success criteria, so we can add that filter to our base query. And we want the success to be false. We can clean out a lot of rest of the query and focus on that core query that shows us the failed calls to our application dependencies or the downstream API calls that we made. For our alert, we just want this raw data. The alert tool is going to create those aggregations for me, so we don't need that. We don't need the time filter, as the alert engine will filter on the timestamps for us. I know, this doesn't look quite right. Let's see. When I've made some changes in the query, it stops returning results. I usually start by removing my changes, which would make it very easier for me to see. Oh, there's where it is. I forgot my double equals. That catches me up every time. But if we can focus on the lines that we have changed, it's really easy to find. Now back to getting some data. We can finish adding our alert criteria. We want our alert query to search the last 30 minutes of record. We want it to evaluate the state every 5 minutes, and we specify how many results we should alert on. Now let's start with 4. We also set a period of 15 minutes. That means that the alert will only fire if we are in an error state for 15 minutes or 3 rounds of evaluation, because it's every 5 minutes. And we can adjust that. If we find our alerts, states, and fires and cancels, and then fires again, it's a state known as flapping. Now, seeing the results from my query, I think I should have gone with a higher threshold. Let's go with 10. So alert will fire if for 15 minutes we have more than 10 errors in the past 30 minutes. The count will be taken every 5 minutes. Now, that's a lot of intervals and numbers. So be prepared to play with that configuration. Next, we have to tell the alert what to do. And that's what action groups are for. We are going to create an action group. An action group is a collection of response capabilities that we have to respond whenever there is something that we should be aware of, anywhere in Azure Monitor. Once you create an action group, it can be reused with multiple alerts. Now, I have to create a name as well as the type of notification. And that's all I want to do. Now, we'll start with the most basic and the worst, the email. Because it's going to be in someone's inbox, probably get read after 3 weeks. Emails are never a great communication mechanism for alerting, but it's where we're going to start. The common alert schema provides a more consistent notification experience, regardless of the type of alert. Now, naming things is hard, and I'm not really good at naming. Now, we'll call this Steve for now, and we're going to come back to it later to add. But this is where we can integrate our automation in response to an alert being triggered. We've got our action group mapped to alert rule. We just have a little bit more to finish up, and then our alert rule will be done. We have some more naming again, and I'm not great at naming. So let's use something wrong. That sounds actionable to me. We'll make the severity a warning, and then we can finally create that alert. Once we create our alert rule in place, we need to identify someone who's responsible for doing something with that alert. Otherwise, it will just sit in someone's inbox. So a red alert comes up in production. Your app is down because calls to external APIs are failing. Email notifications went out to everyone. And as an admin, you think, we're fine. We have an email notification associated with the app health check. But are we? You may all have heard about this story. An email goes out to everyone and no one did anything because they all think that someone will do something about it. Now, disaster response depends on definition of responsibility. A few things to consider. Create a shared plan for DRI. DRI refers to directly responsible individual. Identify a clear escalation path. So if the person happens to be out of office, we can get someone else. Define a response time target. Now, DRI is going to be the person responsible. They will be the direct person who responds to alerts or incidents and coordinate with partners. If the issue is severe or long-running, ensure the proper escalation is there. Now, time for a quick demo. One way that we can improve our incident response is on-call schedule. If you're using Microsoft Teams, we can use the Shifts app to set up that on-call schedule and eventually create some pretty cool automation. Let's get started in setting up that schedule. When Shifts first open up, our team needs to be associated with it. We need to add our team members to scheduling and Shift. We'll just go through here real quick. Now my team is here. Now next we can start to schedule these shifts. For this example, I'm going to use 24-hour shifts because that's the largest chunk of time that we can designate as a particular shift. I'm going to assign people in one-day blocks. We'll go into shifts and we can pick it to start time. I'll use a 24-hour toggle. I like to start my shifts in midday so that there's some time for handover, especially during the week. It's a lot easier to share information when people are online and working rather than at midnight or 6 a.m. Shifts also support a lot of extra information in metadata. But let's start and keep it simple. It's one of my common refrains. The complicated will come after we set up the shift. Now we can copy the shift that we just created and paste it down. And we are just going to work through the calendar here and assign shifts in 2 days at a time per person, so that there's some rotation and no one is on call all the time. Each person is going to have some days off. Now within shifts, we could leave things open or unassigned and people could claim them. People can trade shifts and there's a way to adjust all these things. One of the nice things is once it's shifts and teams, we'll later be able to use a logic app to query and find out who is supposed to be on call at that time of the day. I can share the updated schedule with my team, and once it's published, we can copy it. We can set a particular pattern, and we can pick a start and end date, and we can choose how often to repeat it, and make our scheduling process go a little easier. Now let's discuss some common pitfalls while reporting. Incident notifications are not effective when they're either too broad. That means everyone on the team is notified, and we don't know who should respond. They're just informational only. That means you don't know what to do just by looking at the traffic amount. It is not just checking the app's heartbeat. when you access a certain endpoint and you have a 200 OK status. It is also not just passively picking up everything from the app logs. Now, a good incident notification should be specifically directed to whoever is responsible for it. If we need to increase a memory or a CPU, maybe it's the operations member. If it's a database issue, maybe it's the database admin. If it's an application bug, maybe it's the developer. It should be completely actionable. That means it provides info on how you can act on the incident. And lastly, incident resolving is not magic. Don't just set up a heartbeat check and sit around expecting all incidents will resolve themselves automatically. Some issues just need human intervention after all. Now next, let's add some automation to help us with incident response. Some incidents need humans to resolve, but can we define some automation that will help us? That is why there's great value in automation. Now some basic guidelines. Manual, repetitive tasks are good to be automated. It helps you standardize the response too. It also helps to reduce human interaction to reduce variability in response. Finally, it will protect production by ensuring that the notification and response are done on time. Now time for a quick demo again. Now here's where all of our previous hard work starts to pay off. We're going to wire up all the things that we have worked on so far. We're going to take that alert that we've created for our websites. We're going to take that on-call schedules that we've created, and we're going to wire up some automation so that when there's an alert, we can look up who's on call and notify them on Teams. We can also create a channel for that incident and post some information from that alert into that channel. Now let's get started. We're going to start by creating a logic app. Now, logic apps are going through a bit of a change, right? Well, we want the classic logic app because that's what our alert infrastructure knows about. And we can get that here. So if we go to create logic app and choose the consumption models, and then it's got this little, hey, looking for the old one? Yeah, we'll choose that one. We pick up the subscription that we're going to use, what resource group, and give it a name. Unfortunately, I've not gotten any better at naming things since we set up our alert rules earlier. So new alert, notifier. That sounds good to me. Now, one nice thing about the old style logic app is they create really fast. You submit it, and very shortly after, it's ready to go. Since we'll be working with action groups, we want to use the HTTP request received as a trigger. There's a particular JSON schema that alerts have, and it's provided in the docs, so we can give them the schema to trigger and know more deep information about that alert data. We'll wire up Teams, so we can see how that works. And then we'll hop over to logic apps that have already started. It's got all the workflow configured, and we can really dig in there to see what's going on. Now we're going to start, and we'll search for that Microsoft Teams connector. We've got a lot of capabilities exposed here. We'll start with get a team. I've already authenticated, but I'll show you how we log in. We can add a new connection. It's just going to pop a new window to let me log in. As I mentioned, I'm already authenticated in my browser, so I could click that account. I could also add another account, or if I wasn't signed in, it would give me a login prompt, and I can provide my username and password, use my authenticator app, and all that thing. Now the logic app that will persist that login information for a period of time, and after that, we can run it in our Teams. You can also use a service principal to authenticate for some connections. Now, after all that, we are off to the races. We can start building our logic app. I've already given this a start. So here's our alert notifier logic app. Now let's take a look at what it looks like in the designer and walk through the flow of work happening. It starts off when we receive the HTTP request from the alert. The alert notification make is making that request for logic app. It is going to send a payload that follows the schema. We get our team just like we wired up before, and then we can create the channel. For the channel display name, we are going to use incident-the alert ID. That's coming from the alert data. We can index into the body of that alert, the channel descriptions, the alert rule name. Then we'll ping a message into the general channel and say, hey, there's an incident happening. We'll share the name of the incident and provide link to that channel. Now the links look a little funny in the designer, but they come out really fine in teams. And they work amazingly. And then we have to find the on-call shift. We'll look at the shifts, look around, look the day before, the day after the incident happens. Now we have to encompass the whole shift into search criteria in order for it to return. And then I can filter out anything that's too early or anything that's too late. So we are left with just shifts that cover the time where the incident happened. And there could be more than one shift. We could have an overlap, we could have multiple people on. So for each of those shifts, we'll get an app mention token for the user assigned to that shift. And then we can create a message and teams that app messages for the on-call individuals. So they get a notification, hey, your incident's going on. Here's some information for you. And then we'll post some information in the chat, the time of the alert, the severity, and some context from it. And also a link to Azure portal with the search results and the time bound when it was happening. Now, there's definitely more information than you can get from an alert. So what you really share is up to you. But let's move on and get this logic app wired up with an alert. It's going to just need to go into an action group. We have a Tailwinds Response Actions group already. Now before, we were just doing an email. Now we can add an action. We're going to pick up a logic app. A panel comes out to configure it. But since that logic app was already created in our resource group, Azure just found it. So we tell it to use the common alert schema, which is the schema that we supply to the logic app trigger. The common schema makes it easier to work with other alert sources as well. Now time to give it a name and to save it, and we're ready to go. And once this is all wired up, it's just a matter of time for something bad to happen. Now let's go back over to Teams. And while we are in Teams, I've decided to go ahead and give my teams a heads up about this new functionality. Oh hey, I'm getting a new message. Power Automate just messaged me. That's a logic app. It shares some infrastructure with Power. So it looks like there's some incident happening. We should go out and check that channel. Here's a link to that channel, and it takes us right to that channel where that incident information is coming to us. And that's where I got that message from. And we've got data about that alert, the link to Azure portal, and more. So this is from the query that we just established earlier, just focused on the current time. Now we've got the search results that we can use to start troubleshooting with, or we can go over to Dashboard or Azure Monitor, or wherever really dive into deeper and app insights. Go into a web app, whatever we need to do in our next steps to troubleshoot our problem. But now we really need to set up to kick off our incident response process. Now, if you use Azure, a feature called MS Defender for Cloud is a must-have tool in your toolbox. Microsoft Defender is provided in two tiers. The free tier provides security recommendations based on an assessment template customized for Azure. The enhanced features that include upgrade packages based on different workloads. Example for VMs, it provides just-in-time access control. It also helps to monitor security settings based on those assessments and your Azure inventories. And it also helps to analyze and identify potential attacks. Some intelligent features are backed up by Azure Machine Learning. Microsoft Defender for Cloud is cloud-based, so it works regardless of OS. Enhanced tiers includes a feature called Security Alert, which we can use for many monitoring and maintenance scenarios. Now, there are multiple ways to use Defender for Cloud. Scenario 1, use it for incident response. Security alerts are integrated with other threat protection packages in Defender for Cloud. Example, vulnerability assessment for VMs, built-in analytics for SQL databases to detect attacks, and a whole bunch of other threat protection programs. Many come with a predefined recommendation you can use to respond. Example, VM vulnerability assessment, which can mean to upgrade to a more secure OS version as provided by Defender for Cloud. Now, scenario 2, use it for prevention. Even in free tier, the default recommendation can help you to increase your security. When enhanced features are turned on, you can also configure your own security assessment policy. It watches over the whole subscription, so it works at a whole organizational level. Now, another important security program that can be used with Microsoft Defender for Cloud is Microsoft Defender for Identity. It is part of Microsoft Defender, and unlike Defender for Cloud, which works primarily for Azure, Microsoft Defender works with things like Office 365 or Microsoft 365, which are intended for business users who are not necessarily developers or engineers. Now, Microsoft Defender has its own portal, and you can monitor and respond to suspicious activities there. Microsoft Defender sensors are installed on domain controller traffic, so they can collect traffic information from domain controller without a dedicated server or configured port mirroring. Microsoft Defender for Cloud Service runs on the Azure infrastructure, and it can be connected to Microsoft Intelligence Security Graph as well. In the minimum, this will help you to monitor malicious behavior in much more detail, such as IP address or an associated Office 365 user. Now, that being said, I hope now you see the value of automation is not only in the pipeline, but also in monitoring and maintenance. Now, congratulations, you made it here. This wraps up our session. You can review what we covered and explore more at the learning path aka.ms/AZ400. And if you're interested, do check out the AZ400 certificate associated with it. Again, thank you for attending, and we hope you enjoyed these sessions. Remember, there are many other ways to continue your learning journey, such as Microsoft Learn, where we offer self-paced learning options, and be sure to check the calendar for more Microsoft Virtual Training Day events.